Going to talk a little bit about volume. I don't think that you have the words up in blue on your notes, so go ahead and copy those down. The figure on the left is a rectangular prism. On the right, we got a pyramid. Um, and we're going to find the volume of things like this today. So, volume of a rectangular prism, it's something that you've seen before. You know, when you find volume of something, people normally say length times width times height. Sometimes, like on a formula sheet or something, you'll see something that says volume equals big B times H. And they normally use a little h for height. I use the capital H down here. That was probably not the most correct thing. Length times width times height. There you go, all lowercase. Volume equals big B times H. And when they say that, this big B just stands for the area of the base. Okay, big B stands for area of the base. And so the area of the base on a rectangular prism is that area. There's your base. And so the area of the base on a rectangular prism is length times width times the height. Pyramid is the exact same formula except for it is 1/3. So sometimes you see it as 1/3 big B times little h. So this is volume equals 1/3 length times width times height. Okay. If the pyramid's height is 6 yards, so 6 yards, what is the volume of the pyramid? I got the length, I got the width, I got the height. Let's say volume equals 1/3 length, width, height. I'm just going to plug in those numbers. Times 4 times 5 times 6. That is 40? 40 cubic yards. You know, it's three-dimensional. You're going to have a little 3 up there. The volume of a pyramid is 105 cubic inches. If the length of the base is 7 inches and the width is 5 inches, what is the height of the pyramid? So this one is just a little bit different. You know, I've got volume equals 1/3 length times width times height for a pyramid. It gives me some different information. It doesn't just give me the length, width, and height. It gives me the volume. So I'm going to take this 105 that it gives me for the volume, plug it in where the V is, and get 1/3. Length is 7, width is 5, and I need to solve for that h over there. So this is 105 equals 35 over 3 times h. And you could do a couple things. You could cross multiply. You could multiply both sides by the reciprocal of 35 over 3, which is 3 over 35. If you got a calculator like mine, then it will divide for you by 35 over 3. Divide by 35 over 3. So that's what I like to do with our calculators, just easy. But you can use any of your algebra steps there. And you would get, I believe, 9. Height equals 9 right here. Next, we got a cylinder and a cone. Cylinder and a cone. Cylinder is volume equals pi r squared times the height. Sometimes people write that just like the rectangular prism. Volume equals big B times h. What's the big B stand for? Area of the base. Well, what's the area of the base? What's the area of the base right here? Pi r squared. It's a circle. So sometimes they write this and the prism together at the same time just to save ink, I guess, or be lazy, or I don't know. But sometimes they write it as the same formula. Just know that the cylinder is a little bit different because the area of the base is a circle. Cone, very similar to the pyramid here. I've got 1/3 pi r squared times the height. And likewise, sometimes you see it as 1/3 big B times h. You just got to know that the big B stands for area of the base. Okay, which in this case is pi r squared. If the radius of a cylinder is 9 feet and the height is 35 feet, what is the volume of the cylinder? Radius of cylinder is 9 feet, the height is, all right, well, cylinder volume equals pi r squared times the height. That's pi. It gives me a radius of 9 times the height is 35. That is going to be a ginormous number. 2835 pi cubic feet. Magic arrows. 8906.4 cubic feet. What is the volume of the cone? Couple things to take note of right here. When I find the volume of a cone, its volume equals 1/3 pi r squared times the height. I need my radius and my height. This picture gives me none of them straightforward. The 16 is not the radius. The 16 is the diameter. So the radius is going to be 8. 8. And that 17 is not my height. I need to figure out what my height is. How can I figure out my height? Pythagorean Theorem. So put an X right there, or I guess I could put an H right there. Make it an H. Well, I've got 8 squared plus H squared equals 17 squared. That's 64 and 189. And when you subtract, no, 289. When you subtract the 64 over to 289, I think it's 225. So you get H squared equals 225. That means H equals 15. So that's your height. So punch all that in your calculator. I think you get 320 pi cubic centimeters. Or magic arrows will give you 1,005.3 cubic centimeters. Next, we got a sphere. So a sphere, we can find the volume of that. It has a formula of 4/3 pi r cubed. Pi r cubed here, 4/3 pi r cubed to find the volume of a sphere. So a sphere has a radius of 3 feet. What is the volume of the sphere? It's fairly straightforward. Volume equals 4/3 pi r cubed. And I'm going to punch in 3 for the radius. And that would be 36 pi or 113.1 cubic feet. Okay, this next one on the right is more of a problem that you'll see later on in a homework. A sphere has a volume of 523.6 cubic centimeters. Find the diameter. Okay, so important. Find the diameter. So I'm going to use this formula, volume equals 4/3 pi r cubed. And when I solve, I'm going to get my radius equals something. I got to remember to multiply it by 2 because it wants to know the diameter. So it tells me the volume is 523.6. Okay. And I got to get that R by itself. So if I got a calculator that looks like mine, there's several different algebra steps you could do here, but I'm going to divide by 4/3 pi on both sides. That will leave me with r cubed equals, I think, right at 125. If not, it's really close on a decimal. 125. And then we need to know how to take the cubic root of something. If you got a calculator that looks like mine, make sure that you're cleared, and then you're going to push the 3 and second button, and then it's got a radical and a like little box or something above it, maybe an X above the radical, and it should scoot that 3 up and make it small next to the radical. So try that a couple different ways. Push 3, push second, push that little button that's going to scoot the 3 up. It should be on the left side, close to the x squared or the x to the something or other button. I don't think it's the x squared because that's the regular radical. Try the other one. It should not say 3 square root. It should be like a small 3 up in there, okay? So I'm going to take the cube root of both sides. And when you take the cube root of 125, that's saying something times itself 3 times will give you 125. That answer is 5. Don't forget diameter. Diameter is 10. Cylinder has a radius of 10 centimeters and a height of 9 centimeters. A cone has a radius of 10 centimeters and 9 centimeters. Show that the volume of the cylinder is 3 times the volume of the cone. All right. What I'm going to do is I'm just going to find the volume of the cylinder and find the volume of the cone and say, oh, wow, look, it is 3 times. Like that makes sense, right? So over here, I'm going to do the cylinder. And over here, I'm going to do the cone. So the cylinder is volume equals pi r squared times the height. The cone is volume equals 1/3 pi r squared times the height. So the cylinder up top, it says, has a radius of 10 centimeters and a height of 9. Radius of 10, height of 9. Same thing for the cone, 1/3 pi r squared times the height is 9. And this one should give you 900 pi. This one should give you 300 pi. And I don't know if you know this or not, but 900 pi is 3 times the size of 300 pi. You could make that a decimal, you could divide, all that kind of stuff, and say, oh, it equals 3. You could say, this divided by this equals 3, and that works. But I need some sort of statement right now. So I'm going to write 900 pi is 3 times larger than 300 pi. You could say 300 pi is 3 times smaller than 900 pi. That would be perfectly fine too, okay? What is the volume of a cylinder with a radius of 3 inches and height of 9/2 inches? This is just practicing with fractions. Cylinder is volume equals pi r squared times the height. The radius is 3. The height is 9/2. I think that should be 81 pi over 2 maybe? And you could push magic arrows if you wanted to. That is technically inches cubed. If the diagonal of a square-based pyramid is 5 square root of 2. All right, so we got a square-based pyramid. Square-based. Okay. And the diagonal is 5 square root of 2. The height is 14. What is the volume of the pyramid? So if I want to know the volume of a pyramid, I need what? Length times width times height. I've got the height, but I don't have the length and the width. So I need to find that. What's convenient about a square-based pyramid with the length and the width? They'll be the same thing. So I'm going to give you an aerial view of our square-based pyramid here. So I got a diagonal, and that's 5 square root of 2 right there. If they are the same thing, if this is x, then that's x, right? They're the same thing. You can make it m or y or z or whatever. So I can solve for my sides right there. I can use Pythagorean Theorem. It's a square. It's a right angle. So I could say x squared, a squared plus b squared equals c squared. 5 squared of 2 squared over there. This would be 2x squared equals, that's 25. I think it's 50. Divide by 2. X squared equals 25. X equals 5. Another way you could go about this, since it's a square, like, since you cut a diagonal, that would be 45 degrees. You could do sine, cosine, tangent if you wanted to. You could say sine is opposite over hypotenuse. Sine of 45 equals x over 5 squared root of 2 if you wanted to, if you felt better about that than Pythagorean Theorem. Anyways, I got x equals 5. So if the length is 5, the width is 5, I can punch all that into my calculator, and it'll give me 350 over 3. 350 over 3, which is 116.67 cubic meters. Which of the following statements is true? Then say why. Correct answer. We got this cylinder on the left, cylinder on the right is kind of tilted a little bit. They have the same diameter. They got the same height. Correct answer is they have equal volumes. I don't know why. I always want to say the one on the right. Like, it just looks bigger, but it's not. They are equal in volume. Okay? I always think about like a stack of paper. If you had some printing paper, you got some like a package of printer paper, you rip open the package, you got a stack of like 500 sheets of paper. And you said that that stack of printer paper had a volume of whatever, I don't even, 1,000 cubic centimeters. I don't know what it is. But if it had a volume of 1,000 cubic centimeters and you were to like tilt it over, so it was looking like this kind of, and then you were to kind of push it over to where it looks kind of like this one, the volume would still be 1,000 cubic centimeters. You'd still have the same amount of paper. It would just be tilted over. Okay? And that's because each little slice of paper, like if you took a little slice of paper out, each one, the fancy term is cross section. Every cross section in that stack of paper has the same area. Okay? Every cross section, and it goes all the way up. That's what's known as Cavalieri's principle. That's on the left. Cavalieri's principle doesn't exist. There's a fun story about that. I'll tell you one day when you get into class, okay? Cavalieri's principle. Jason constructed 2 cylinders using metal washers. The cylinders have the same height, but one of them is slanted. Okay, so these say washers. One of them bothers me is because I think washers should have like a hole in the middle to make them useful. But anyways, these should be more like quarters. That's beside the point. I'm thinking of stacks of paper because that makes more sense to me. So I got, my stack of paper right here. Then this one I kind of pushed over a little bit, stack of paper. Which statement is true about Jason's cylinders? The cylinders have different volumes. Well, they don't have different volumes. Wrong. The cylinders have different volumes. Wrong. I know they're going to be the same. It's what we just talked about with the stacks of paper. So it's going to be one of these last two. The cylinders have the same volume because each washer has the same height. I don't know. Let's read D. The cylinders have the same volume because they have the same cross-section. Look at that. That's that fancy phrase I used earlier. Have the same cross-sectional area at every plane parallel to the basis. So that was a really fancy way of saying, if these are stacks of paper up top, that sheet of paper has the same cross-sectional area as that sheet of paper. This one right here, same as that one right there. All the way to the top, they have the same volume. Okay? So let's find a couple more to work. So this says that AB is the radius of the cylinder and the sphere. The sphere's radius touches the top and bottom of the cylinder. AB is 8 centimeters in length. Okay, so AB is 8 centimeters in length. How many cubic centimeters are left if the sphere is removed? Well, I'm going to have to find the volume of the cylinder, and then I'm going to subtract the volume of the sphere. So once I got the volume of the cylinder, I'll subtract the volume of the sphere, and let's go from there. So it says that the radius touches the top and bottom, so that means that the height is going to be 16, right? So I've got pi r squared times the height minus 4/3 pi r cubed. And I'll punch all that into my calculator, and it will give me 1024 pi over 3, or I got 107 and change. I can't see the rest of my answer here. $1,072.33. Okay. And that would be in cubic centimeters. That would be what's left over. Okay. I would do something similar right here. If I wanted to find the volume of this figure, I'm not going to subtract anything. I'm going to add them. So I'm going to find the volume of the cone, and then I'm going to add it to the volume of the cylinder. So I've got cone is 1/3 pi, radius would be 3, right? Pi r squared times the height would be 9 for the cone, plus pi r squared times the height for the cylinder is 10. And I punch all that in my calculator. I get, I think, 117 pi. Hopefully, my math checks out on that. That would be 367.5 cubic inches.